Nice. Welcome to Eco Engineer. Today we will discuss about halfway rectifier I have completed in this previous video. Now we have come to discuss about full wave rectifier and the basic construction structure of a full wave rectifier and the input and output waveforms of a full wave rectifier. Now let's go to the topic. Here the full wave rectifier. Full wave rectifier converts an AC voltage into a pulsating DC voltage using both half cycle of the applied AC voltage. In the previous, the half wave rectifier, the only half of the circle can be converted to a period of the AC voltage. Here, the full wave rectifier, both half cycles of the AC input voltage can be converted into a DC voltage. This is called as a full wave rectifier. It is used two diodes of which one conducts during one half cycle while the other diode conducting during the other half cycle of the applied AC voltage. The figure 2 shows the basic circuits and waveforms of a full wave rectifier. Here we have to see that here this is input voltage, sinusoidal wave signal or the AC voltage. This is an output voltage here V0. Here this is a full wave rectifier. This is a diode D1, the diode D2. Here the primary coil in the secondary coil. The secondary coil contains the two diodes which is converted in the series. The load resistance is connected in the parallel to the rectifier. Here, this is the full wave rectifier, also called as a center tap transformer. Here, I have to discuss about the full wave rectifier is also called as center tap transformer. Okay, this is called as a basic structure of an full wave rectifier. When the positive half cycle, the diode D1 act as a forward bias. Because of this anode give the value positive, this cathode give the value negative, then diode D1 act as a forward bias, the diode D2 act as a reverse bias when the positive half cycle. When the negative half cycle, the diode D2 act as forward bias, the diode D1 act as a reverse bias direction due to the terminals of the anode and cathode terminals of the diodes. Here, the first positive half cycle diode D1 act as forward bias, the negative half cycle diode D2 act as a forward bias. Okay, we have observed this the waveforms in the structure. We have to see in the basic structure of a full wave rectifier. This is a input and output waveforms of a full wave rectifier. We have seen that this is called as a input sinusoidal wave signal or input AC voltage. This is called as output of a diode A. Okay, when the diode 1 నుంచి వచ్చిన waveforms ఇవ్వండి. Okay, then the positive half cycle, and the positive half cycle, and the positive half cycle. Okay, this is positive half cycle, positive half cycle, this positive half cycle, positive half cycle, this positive half cycle, positive half cycle. The negative half cycle, the diode D2 కాబట్టి out of output of diode D2 is this diode D2 can be act as forward bias. That's the waves can be formed in forward bias. The total output is nothing but a D1 here, output of D1 plus output of D2, nothing but this wave plus this wave, and so this wave, similarly this wave, similarly this wave. All this total output of the full wave rectifier. Okay, the all are positive half cycles because of the two diodes are conduction mode. When the positive half cycle D1 act as forward bias, the negative half cycle D2 act as forward bias. Okay, the negative half cycle D1 act as reverse bias, the positive half cycle D2 act as reverse bias condition. Now we have to describe about some points చూడండి ఇక్కడ. The positive half cycle, the D1 act as a reverse bias. Okay, when the D1 acts as forward bias, not the reverse bias. When D1 acts as forward bias, when this is conduction mode, when a positive half cycle, D2 acts as a reverse bias. This is an open circuit, is not conductance. Okay, when the negative half cycle, the diode D2 act as a forward bias. It is conduction mode. When the negative half cycle, the diode D1 act as a reverse bias, does not conductance of current. Okay, this is the important logic of full wave rectifier. Now describe about the description of full wave rectifier. During positive offs of the input signal, anode of the diode becomes positive, and the same time the anode of diode D2 becomes negative. Hence, D1 conductance and D2 does not conduct. The load current flows through D1 and the voltage drop across RL will be equal to the input voltage. Whenever the load current flows through the D1, the voltage drop across the load resistance RL. Again, this is called as input voltage, which is equal to the input voltage. During negative off cycle of the input, the anode of the diode D1 becomes a negative. The anode of diode D2 becomes positive. Here, whenever the negative off cycle, the diode D2 has forward bias direction. The diode D1 is act as a reverse bias direction when the negative off cycle. Hence, D1 does not conduct and D2 conduct. Whenever this one happens and when D1 is not conduct, D2 is conduct. Which bias? When positive half cycle, diode D1 does not conduct, D2 conductance. Okay, the load current flows through D2 and the voltage drop across RL will be equal to the input voltage. Okay, when the load current flows through D2 and the voltage drop across RL will be equal to the input voltage. This is when the full wave positive half cycle and negative half cycle will be form a DC signal. Okay, in this process, both a positive half cycle and negative half cycle can be forming a DC signal in output wave. That's why which is called as a two half cycles can be used in to form a DC voltage is called as full wave rectifier. Okay, guys, now observe this one. When the positive half cycle, the diode D1 has forward bias, diode D2 has negative reverse bias. When the negative half cycle, diode D1 has a reverse bias, diode D2 has a forward bias. This is a condition for full wave rectifier. Thank you. Thank you, guys.